This is the first video for the summer packet that is due the week you get back, and we're going to do a quick review of classifying numbers. All right. For right now, we're going to stick to a real number system, and the real number system contains, let's see, 1, 2, 3, 4, 5 subcategories. The smallest of these subcategories is the counting numbers. It's almost like when you're watching Sesame Street with the count. 1, 2, ha ha ha, 3. And that pattern will continue forever and ever and ever. So those are the simplest of the numbers, accounting, and also called natural numbers. After that, we have something called whole numbers. Now, I'm showing that these are smaller sets because they flow into, let me put that in the right spot. Eraser's a little bad. I'm going to put whole numbers right here. All the counting numbers are, in fact, whole numbers. So the whole number system actually only contains one more. It's the number 0. So 0, 1, 2, we'd go 3, 3, 4, 5, 6, 7, dot, 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 on to infinity. All right. Now, the next one, when you get into probably 5th, 6th, 7th grade, they introduce you to integers. Something tricky about integers, everyone thinks it's something with just a sign, like a positive or a negative. That's totally true. The actual definition of integers is positive or negative whole numbers. So I could have a -3 and a +3. But there are no fractions. There are no fractions and no decimals, just positive or negative whole numbers. So once again, all counting numbers are whole numbers, all whole numbers are integers, and all integers are also within this next group. And this next group is called rational numbers. All right. Rational numbers, if you look it up again, it's an integer divided by an integer. So obviously it includes fractions. There's a few key moments. So -3.1 would be a rational number, no longer an integer because it's got a decimal in there. You can't have decimals. I mean, fractions are really just decimals that we cannot give a base of a multiple of 10 to, right? This is actually 21 hundredths. I think I said that correctly. I mean, decimals are really just fractions. We write a little bit different. This would be 1/10. That would be -1/10. All those could be rational numbers. All right. What may not be a rational number is a number that never repeats and never terminates. So a number like this that is a decimal that doesn't repeat or doesn't terminate is not rational. We reserve those numbers for something called irrational. Irrational numbers have decimals that never ever repeat or terminate. The most common of those that you see very often is pi. Also, any radical that's not a perfect square root. But if you see something that has, like, let's say 0, and then we go 1, 2, 5, 7, 6 with no discernible pattern, and then they say it continues forever with no discernible pattern, that would also be an irrational number. Now, just so you know, if you're a counting number, you're also a whole, an integer, and a rational. If you're a whole, you're also an integer and a rational. If you're an integer, you're also a rational. And everything on here is a real number. So none of these groups are within the irrational numbers, but all of these groups are within real numbers. And I'm going to give you one example. It says list all of the groups each one belongs to. So I'm going to do your first problem. Your first problem says -4. So I'm going to say the first one I see negative numbers and our decimals in. All right, so this actually lists all the groups this number belongs to. It's definitely an integer. Let's see, can I go into whole numbers? No, because there's a negative number. But I can go out. All integers are also rational. All right. I'm going to go ahead and list real numbers, although I don't think this requires you to list real numbers. But that is the first 10 problems on your web page. Well, I haven't put it on the web page yet, but on your review packet for your summer packet. Thank you very much. You guys work hard.